So what is machine learning? In this video, we'll try to define what it is and also give you a couple of examples. It turns out that even among machine learning practitioners, there isn't a very well-accepted definition of what is and what isn't machine learning. But let me show you a couple of the ways that people have tried to define it. Here's a definition of what is machine learning that's due to Arthur Samuel. He defined machine learning as the field of study that gives computers the ability to learn without being explicitly programmed. Samuel's claim to fame was that back in the 1950s, he wrote a checkers playing program. And the amazing thing about this checkers playing program was that Arthur Samuel himself wasn't a very good checkers player. But what he did was he had the program play tens of thousands of games against itself. And by watching what sorts of board positions tended to lead to wins and what sort of board positions tended to lead to losses, the checkers playing program sort of learned over time what are good board positions and what are bad board positions, and eventually learned to play checkers better than Arthur Samuel himself was able to. And those are remarkable results, right? So Arthur Samuel turned out not to be a very good checkers playing program. But because you had a computer play, the computer has a patience to play tens of thousands of games against itself. Like, no human has a patience to play like tens of thousands of games against a computer. And by doing this, the computer was able to get so much checkers playing experience that eventually it was a better it eventually became a better checkers player than Arthur Samuel himself. So those are somewhat informal definition, an older one. Here's a slightly more recent definition due to Tom Mitchell, who's a friend out in Carnegie Mellon. So Tom defines machine learning. He says a well-posed learning problem is defined as follows. He said a computer program is said to learn from an experience E with respect to some task T and some performance metric P. If its performance on T as measured by P improves with experience E. I actually think he came up with this definition just to make it rhyme. So for the checkers playing example, the experience E would be the experience of having the program play tens of thousands of games against itself. The task T would be the task of playing checkers, and the performance measure P would be, let's say the probability that it wins the next game of checkers against some new opponent, say. Okay. Throughout these videos, in addition to me, trying to teach you stuff, I'll also occasionally ask you a question to hopefully make sure that you understand the content. So here's one. On top is that definition of machine learning, right, by Tom Mitchell, right? And let's suppose that your email program watches which emails you do or do not flag as spam email. And based on which emails you mark as spam, based on that, it learns how to better filter spam email. What is the task T in this setting, right? So, here's my email client, but so, right, with the spam email, we tend to click the spam button. And let's say that by watching me do that, my email software gets a better spam filter. So in Tom Mitchell's definition, what would be the task T in this setting? In a few seconds, this video will pause, and you should then please use your mouse to select which one of these 4 buttons you think is the correct answer. All right, so hopefully you got that that's the right answer. And in fact, this definition defined experience E, performance measure P, and a task T. So classifying emails is a task T. Watching you label emails, that's the experience E that the system learns from, and the fraction of emails correctly classified, that's perhaps our performance measure P that the system will improve on after this experience E. In this class, I hope to teach you about various different types of learning algorithms. And it turns out that there are several different types of learning algorithms. The main 2 types are what we call supervised learning and unsupervised learning. And I'll define these terms more in the next couple of videos. But it turns out in supervised learning, the idea that is we're going to teach the program how to do something, whereas in unsupervised learning, we're going to let it learn by itself. And don't worry if these terms don't quite make sense yet. In the next 2 videos, I'm actually going to say exactly what these 2 types of machine learning are. You may hear other buzz terms called reinforcement learning, recommender systems. These are other types of machine learning algorithms that we'll talk about later. But the 2 most used types of learning algorithms are probably supervised and unsupervised learning. and I'll define them in the next two videos, and we'll spend most of this class talking about these two types of learning algorithms. It turns out that one of the other things we're going to spend a lot of time on in this class is so practical advice for how to apply learning algorithms. And this is something I feel pretty strongly about, and it's actually something that I don't know of any other university that teaches. It turns out that learning about, so teaching you about learning algorithms is a bit like giving you a set of tools. But the equally more important thing, or maybe more important thing, is to teach you how to apply them. I like to make an analogy to, if we're learning to be carpenters, right? So imagine that someone were teaching you how to be a carpenter, and they would say, okay, here's your hammer, here's a screwdriver, here's your saw, good luck. That's no good. You have all these tools, but the important thing is to learn how to use these tools properly. It turns out there's a huge difference between people that know how to use these machine learning tools in practice versus people with that don't know how to use these tools well. Here in Silicon Valley, where I live, when I go visit different companies, very often, even the top Silicon Valley companies, very often I see people trying to apply machine learning algorithms to some problem, and sometimes they'll have been going at it for like 6 months. But sometimes when I look at what they're doing, it's sort of like I can tell them, gee, I could have told you 6 months ago that wasn't going to work, and you should be taking your learning algorithms and applying it in like that slightly different way instead, and that has a much better chance of working. So what I'm going to do in this class is actually spend a lot of time talking about how, if you're actually trying to develop a machine learning system, how to make the sort of best practices type decisions about the way in which to build your system, so that when you're applying a learning algorithm, you're less likely to end up, one of those people that end up pursuing some path for 6 months that maybe someone else could have just told you 6 months ago wasn't going to work at all. So I'm actually going to spend a lot of time teaching you that sort of best practices as well in machine learning, and how to actually get this stuff to work, and how we do it here in Silicon Valley. And hope to make you one of the best people at knowing how to design and build serious machine learning systems. Okay, so that's machine learning, and these are the main topics I hope to teach. And in the next videos, I'm going to define what are supervised and what are unsupervised learning algorithms, and when you would use each of them.